This presentation covers Chapter 3, Theory Building, from the 9th edition of Business Research Methods. It aims to define theory and explain its goals, components, and the process by which it's developed. Welcome to our class on Business Research Methods. Today, we're going to cover Chapter 3, which is all about theory building. Before we dive in, let's look at our learning objectives for this session. By the end of this chapter, you should be able to master these 5 key areas. 1. Define the meaning of theory. Face with monocle first, we'll answer the fundamental question, what is a theory? A theory is a formal, logical explanation of some events that includes predictions of how things relate to one another. Think of it as a map that helps us make sense of the world. When you flip a light switch and the light doesn't come on, you immediately start forming theories. Is the bulb up? Is the power off? To explain the situation. That's the core idea. To understand the goals of theory. Why do we bother with theories? They have 2 main goals: understanding, to explain why certain events and relationships occur; predicting, to forecast what is likely to happen in a given situation. 3. Understand key terms. Next, we'll break down the building blocks of any theory. It's crucial you understand the difference between these 4 terms. Concepts. These are generalized ideas about a class of objects, attributes, or processes. Words like leadership, customer satisfaction, or brand awareness are all concepts. They exist on a ladder of abstraction, from very general ideas like assets down to concrete realities like a specific punch press. Propositions. These are statements that explain the logical connection between concepts at an abstract level. For example, treating employees better will make them more loyal is a proposition. Hypotheses. This is where we get practical. A hypothesis is a formal statement of an unproven proposition that is empirically testable. We take the abstract proposition from before and make it measurable. Giving employees 1 Friday off each month will result in lower employee turnover. Variables. A variable is the empirical assessment of a concept. It's anything that can assume different numerical values. In our hypothesis, employee turnover is a variable that we can actually measure. 4. Discuss how theories are developed. We will also discuss how theories are actually built. This involves a process of moving from abstract ideas to concrete, testable statements. Researchers use 2 main types of reasoning to do this: deductive reasoning, moving from a general theory to a specific, testable conclusion; inductive reasoning, establishing a general principle based on observing specific facts. 5. Understand the scientific method. Microscope. Finally, all of this is governed by the scientific method. This is a set of prescribed procedures for establishing theoretical statements, analyzing empirical evidence, and predicting events. We will walk through the key steps in this process, from assessing existing knowledge and formulating hypotheses to acquiring and analyzing data to propose an explanation. So, those are our goals for today. Let's get started. Alright class, let's move on to our next slide. So, we've talked about what a theory is in a formal sense. But let's bring it back to the real world. How do theory and practice actually connect? I want you to imagine a very simple, everyday scenario. You walk into a dark room, you flip the light switch, and nothing happens. What's your immediate reaction? You don't just accept the darkness, right? Your brain immediately kicks into gear. You start to seek a logical explanation for why the light isn't working. Your past experience would guide your thoughts. You might think, Maybe the light bulb is burned out. Is it possible there's a power outage on my street? Did I forget to pay the electricity bill? This simple, automatic process of trying to explain an unexpected event is exactly what theory building is all about. You are, in that moment, acting as a researcher. You're trying to find a cause for an effect. In a more formal academic sense, a framework like attribution theory, for example, helps us understand how we explain the causes of our own and others' behavior. It's just a more structured way of doing what our brains do naturally, trying to explain the world around us. So you see, theory isn't just something abstract that we read about in textbooks. It's something we practice every single day. Okay, let's focus on slide 4. So, we've just discussed the intuitive idea of theory using the light switch example. Now, let's get a bit more formal. What is the academic definition of a theory? As you can see on the slide, a theory is defined as a formal, logical explanation of some events that includes predictions of how things relate to one another. Let's break that down. The key words here are formal and logical. This isn't just a random guess like our light switch example. A scientific theory is a carefully constructed framework, built on principles and evidence, that explains the relationship between different phenomena. It's about connecting the dots in a structured way. The goals of theory. So, why do we develop these theories? What's the point? The slide highlights two primary goals: understanding and predicting. First, understanding. The most basic goal of a theory is to help us understand why something happens. Why does a certain marketing campaign lead to higher sales? Why does a particular leadership style result in higher employee morale? A good theory provides a deep, meaningful explanation for these kinds of questions. It gives us the why behind the what. Second, predicting. Once we understand the relationships between things, we can start to make predictions. If our theory about employee morale is correct, we should be able to predict what will happen to turnover rates if we change the leadership style. This predictive power is incredibly valuable, especially in a business context. It allows us to anticipate outcomes and make better informed decisions. So, in short, a theory gives us the power to both explain the past and forecast the future. These two goals are the driving force behind all the research we'll be discussing in this course. So, what exactly is a research concept, or as it's also called, a construct? As the slide says, it's a generalized idea about a class of objects, attributes, occurrences, or a process that has been given a name. That's the textbook definition, but let's make it simpler. A concept is basically a label we put on a complex idea so we can talk about it, measure it, and study it. Look at the examples on the slide. They're all things we talk about in business, right? Leadership, this isn't one single action. It's a whole collection of behaviors, traits, and outcomes. We package all of that into the single concept of leadership. Morale, you can't hold morale in your hand. It's an abstract idea representing the collective attitude or spirit of a group. Gross domestic product, GDP. This is a concept economists created to represent the total value of goods and services in a country. Assets, customer satisfaction, and market share, these are all concepts we use to understand and measure business performance. These concepts are the essential building blocks. Before we can build a theory about how to improve customer satisfaction, we first need to agree on what customer satisfaction actually is. These concepts give us a shared language to begin our research. Now, this is something you're all intuitively familiar with, right? Think about your connections on LinkedIn, your friends on Instagram, or even the network of contacts you have in your phone. This isn't just a random collection of people, there's a structure to it, and that structure has value. That's what social network theory is all about. As the slide says, researchers have developed formal theories to explain the links, the connections, and structures of these networks. And notice the language they use. These theories are complete with constructs and propositions, the very building blocks we just discussed. Constructs in this theory might include concepts like nodes, the individuals in the network, ties, the relationships between them, and centrality, how important a person is within the network. Propositions would then explain how these concepts relate. For example, a proposition might be, individuals with more diverse ties in their network have greater access to novel information. The slide also mentions that these theories help us understand the social capital that networks yield. Social capital is a powerful idea. It's the value that comes from your connections. It's the job opportunity you hear about from a friend of a friend, the advice you get from a mentor, or the support you get from your community. It's the idea that your network is a valuable asset. So, social network theory is a perfect illustration of how we take a real-world phenomenon, break it down into concepts, and build a logical framework to understand and predict how it works. Now, this might sound complicated, but the concept is actually quite intuitive. Think of it as a way to organize our thinking. The ladder of abstraction is simply a way to structure concepts in a sequence, moving from the most general and abstract ideas at the top, down to the most concrete and individual things at the bottom. The slide breaks this down into two levels, the abstract level and the empirical level. The abstract level first. Let's look at the abstract level. As the definition says, this is the level of knowledge expressing a concept that exists only as an idea or a quality apart from an object. In simple terms, this is the world of ideas. Think about the concept of fruit. You can't hold fruit in your hand. Fruit is a general category, an idea that exists in our minds. The same goes for business concepts like success, innovation, or assets. These are all abstract concepts. They're at the top of the ladder. The empirical level now. Let's look at the other end of the ladder, the empirical level. The slide defines this as the level of knowledge that is verifiable by experience or observation. This is the world we can see, touch, and measure. This is reality. So, if fruit is our abstract concept at the top of the ladder, what's at the bottom, on the empirical level? An actual apple. You can hold it, you can bite into it, you can observe its color and weight. It's concrete. The goal of research is often to connect these two levels. We start with an abstract idea, like customer satisfaction, and we figure out how to measure it at the empirical level, for example, by using a survey to ask specific customers about their specific experiences. We're constantly moving up and down this ladder, from the world of ideas to the world of observable reality. This is how we bridge the gap between a big, fuzzy idea and something we can actually point to in the real world. Let's start at the very top of the ladder. Here we have the word asset. This is a highly abstract concept, right? An asset could be anything from cash in the bank, to a building, to a brand's reputation. It's a very broad, general category. It exists purely as an idea. Now, let's take one step down the ladder. The concept becomes a little more concrete. We move from asset to plant and equipment. We've narrowed it down. We're no longer talking about cash or reputation, we're focused on the physical things a company uses to operate. It's still a fairly general category, but it's less abstract than just asset. Take another step down. Now we're at factory machinery. Even more specific. We're not talking about office chairs or delivery trucks anymore. We've zeroed in on the machinery inside a factory. Finally, we arrive at the bottom of the ladder, at the empirical level. Here we have a punch press. This isn't an idea anymore. This is a real, tangible object. You can see it, you can touch it, you can watch it operate. It's a specific instance of all the abstract categories above it. So, this ladder is a great way to visualize the process that researchers go through. We often start with these big, abstract concepts at the top, and we have to systematically work our way down to find something specific and measurable at the bottom. This is how we take a theory and make it testable in the real world. This brings us to a really important idea in research called a latent construct. Now, a latent construct is a concept that we can't observe or measure directly. You can't see it, you can't touch it, but we know it's there because we can see its effects. It's a bit like the wind. You can't see the wind itself, but you can see the leaves rustling and feel it on your face. A perfect example from your slide is salesperson job performance. Think about it. How do you actually see job performance? You can't. It's not one single, tangible thing that you can point to. It's an abstract concept. So, how do we measure something we can't see? We have to measure it indirectly. We bring it down from the abstract level to the empirical level by looking at other, related things that we can observe and measure. For salesperson job performance, we might look at the number of sales calls they make each week, the number of actual sales they close per month, the total dollar value of those sales. Each of these is a concrete, measurable piece of data. By combining them, we get a much clearer picture of the latent construct we're trying to study, which is overall job performance. So, remember, a latent construct is an abstract concept that we measure by looking at its observable parts. This is a crucial step for making our theories testable in the real world. On this slide, we're looking at the difference between propositions and hypotheses, two fundamental elements in building theory. Let's start with a proposition. A proposition is a statement that explains the logical relationship between two or more concepts. It doesn't have to be tested, yet it simply proposes that a general connection exists. For example, treating employees better will make them more loyal employees. This is a broad idea suggesting a universal link between how employees are treated and how loyal they become. Then we have the hypothesis. A hypothesis is a formal, testable version of a proposition. It translates the general statement into something that can be measured using data. For instance, from the earlier proposition, we can form a hypothesis like, giving employees one Friday off each month will result in lower employee turnover. See the difference? The proposition expresses a general relationship, something we believe to be true in principle, while the hypothesis specifies how we can test that relationship empirically. In research, hypotheses are essential because they allow us to move from theory to data, from abstract ideas to measurable evidence. When we test hypotheses, we're essentially testing whether the theoretical propositions we started with hold true in the real world. After we develop a hypothesis, the next step is to test it empirically, meaning, we compare what we expect to happen with what actually happens in reality. Empirical testing involves examining a research hypothesis against real-world data. We collect information, measure variables, and analyze results to determine whether the hypothesis is supported or rejected. Now, let's break this down further. A variable is anything that can take on different numerical values. It represents how we bring a concept into measurable form. For example, employee satisfaction, sales growth, or customer loyalty can all be variables if we find ways to measure them. This process is called operationalizing or operationalization. It means identifying the actual measurement scales or indicators we'll use to assess our variables of interest. For instance, if we want to measure employee satisfaction, we might use a questionnaire with Likert scale questions, or if we want to measure loyalty, we might look at turnover rates. Through operationalization, we turn abstract concepts into measurable data. Once we gather the data, we perform analysis statistical tests to see whether our hypothesis holds true. If the data supports it, we can say our hypothesis is confirmed. If not, we may need to revise it or re-examine our assumptions. So, empirical testing is the bridge between theory and evidence. It's what makes our research scientific, credible, and verifiable. Now, let's take a look at this example of a variable operationalization table, or in Bahasa Indonesia, tabel operationalisasi variable. This table is a very important component in empirical research, especially when you are preparing to test your hypotheses. It shows how abstract concepts such as customer satisfaction, loyalty, or motivation are translated into measurable variables, indicators, and scales. Let's go through a few examples together. The first concept here is customer satisfaction. The variable is the level of customer satisfaction, and it can be measured through several indicators. For example, satisfaction with product quality, price, and after-sales service. Each of these can be rated using a Likert scale from 1 to 5, where 1 means very dissatisfied and 5 means very satisfied. The next one is customer loyalty, which we measure through indicators such as repurchase frequency, willingness to recommend, and length of time as a customer. This may be measured using frequency data or Likert scales as well. Moving on, we have employee performance measured through productivity, attendance, or presence, and achievement of work targets. Here, we use ratio or percentage scales, for example, number of units produced per day or attendance rate. Then we have brand awareness, which looks at how well consumers remember or recognize a brand. Indicators include spontaneous recall, aided recall, and recognition of a logo or slogan. These can be measured using nominal scales, such as yes/no responses, or Likert-type questions. Finally, work motivation is an intrinsic factor. It includes enthusiasm to complete tasks, willingness to work overtime, and initiative to offer new ideas. Again, this is often measured with a Likert scale from 1 to 5. So, overall, this table helps researchers clearly define how each variable will be measured in the field. It provides consistency, transparency, and validity in the data collection process. Without such operational definitions, it would be difficult to ensure that your measurements are accurate and comparable across respondents or studies. Now, let's focus on empirical testing, which is one of the most critical parts of the research process. When we talk about empirical testing, we mean examining our hypothesis against reality, comparing what theory predicts with what the data actually shows. To do this, we use variables. A variable is anything that can take on different values. For example, sales revenue, customer satisfaction score, or employee attendance rate. All of these can vary and therefore can be measured. Remember, in research, variables are the empirical representation of concepts. They allow us to bring abstract ideas, like loyalty or motivation, into something we can observe and analyze. This process is known as operationalizing a variable. Operationalization means deciding how you will measure each variable. For instance, if our concept is employee motivation, we might measure it using a questionnaire on a 1 to 5 Likert scale. Or, if our variable is sales performance, we could measure it in terms of total revenue or growth percentage. The goal of operationalization is to make sure that our concepts are measurable and consistent across different respondents or contexts. Once variables are defined and data are collected, we use empirical analysis, typically through statistical tests, to determine whether our hypothesis is supported or rejected. In short, empirical testing transforms a theoretical idea into measurable evidence. It's Now, this slide exhibit 3.3 illustrates how hypotheses serve as the empirical counterparts of propositions. Remember earlier, we said that propositions are general statements linking concepts, such as treating employees better will increase their loyalty. That's a theoretical relationship. It sounds logical, but it hasn't yet been tested. The hypothesis, on the other hand, is a specific, measurable version of that proposition. It turns abstract logic into something that can be tested with data. For example, a proposition might say, employees who feel valued tend to stay longer in the company. The corresponding hypothesis could be, employees who receive regular recognition will have a 20% lower turnover rate compared to those who do not. Do you see the difference? The proposition provides the conceptual link between ideas, while the hypothesis gives us a testable statement based on observable variables. So, when we say that hypotheses are the empirical counterparts of propositions, we mean that they translate theoretical logic into measurable evidence. This relationship is what connects theory and data. Theory provides the reasoning, while empirical testing provides the proof. Together, they form the scientific foundation of business research. Now, this slide exhibit 3.4 provides a simple but powerful example of how a theory can be built to explain a real-world business problem: voluntary job turnover. Voluntary turnover means employees who choose to leave the organization, not because they are fired, but because they decide to resign. This model illustrates how we can connect multiple concepts through logical relationships and measurable variables. For example, the theory may start with the concept of job satisfaction. If employees are dissatisfied, maybe because of low pay, poor management, or lack of recognition, this leads to lower organizational commitment. In turn, when commitment drops, the intention to quit increases. And finally, this results in actual turnover, employees leaving the company. Notice how each link in this chain can be translated into a testable hypothesis. For instance, lower job satisfaction will lead to lower organizational commitment. Lower commitment will increase the intention to quit. A higher intention to quit will result in higher employee turnover. Together, these hypotheses form an integrated theoretical framework, a cause and effect model that can be tested using empirical data. This example shows that building theory is not about guessing, it's about connecting ideas logically, identifying measurable variables, and then validating those relationships through observation and data analysis. Now, let's talk about the two main reasoning approaches used in theory building, deductive and inductive reasoning. These two are like the yin and yang of research logic, they complement each other. Deductive reasoning moves from the general to the specific. It starts with a known theory or established principle and then applies it to a particular case or context. For example, suppose the general theory says that employee motivation leads to higher productivity. If we apply this to a specific company and test whether motivated employees there indeed perform better, we are using deductive reasoning. In this approach, we already have a theory, and our goal is to test it to confirm whether it holds true in a specific situation. That's why deductive reasoning is most often associated with quantitative research. On the other hand, inductive reasoning works in the opposite direction, it goes from the specific to the general. Imagine observing several organizations where employees with strong mentoring relationships show higher performance and loyalty. After seeing this pattern repeatedly, we might propose a new theory that mentorship enhances employee retention and performance. That's induction. We build new theoretical insights based on real observations. This approach is commonly used in qualitative research, where patterns, themes, or meanings emerge from the data. So, to summarize, deduction tests existing theories. Induction builds new ones. And in practice, most good research involves a bit of both. We use inductive reasoning to develop new ideas and deductive reasoning to test them empirically. This cycle of reasoning is what keeps theory and practice connected, ensuring that our research both explains and improves the real world. Now we've reached one of the most important parts of research, the scientific method. The scientific method is a structured, logical, and systematic approach to discovering truth. It connects theoretical ideas with empirical evidence, helping us ensure that our conclusions are reliable, valid, and repeatable. According to Zygmunt and colleagues, the scientific method provides a set of prescribed procedures for establishing and testing theoretical statements, analyzing data, and predicting outcomes. Let's go through the steps one by one. Step 1. Assess relevant existing knowledge. Before doing any study, we review what is already known: theories, prior studies, and facts about the phenomenon. This helps us identify what gaps still exist. Step 2. Formulate concepts and propositions. Based on that knowledge, we define our key concepts like satisfaction, performance, or loyalty and describe how they might be related. Step 3. State hypotheses. Here, we turn propositions into empirically testable statements. This makes the research measurable and objective. Step 4. Design research to test the hypotheses. We decide how to collect and analyze data, for example, through surveys, experiments, or case studies. This is where the research design and sampling methods come in. Step 5. Acquire empirical data. We collect data from respondents, experiments, or observations using reliable instruments. Step 6. Analyze and evaluate data. We use statistical tools to test whether our data supports or rejects the hypotheses. This step transforms raw data into meaningful information. Step 7. Propose an explanation and state new problems. Finally, we interpret the results, link them back to theory, and identify new questions that emerge, continuing the cycle of discovery. This process shows that science is not just about finding answers, it's about asking better questions each time. So, the scientific method gives us a disciplined pathway from theory, rightward arrow, hypothesis, rightward arrow, data, rightward arrow, conclusion, rightward arrow, new theory, ensuring that our knowledge builds logically and systematically over time.